Hello, everyone. In this video, we will look at how to implement a map using hashing. So please note that in the Python language, and we actually call this as the dictionary, but a map is another name. So we said this is the implementing a map. So this is here map using hashing. So now we're going to design it. We design map. It's the same as a dictionary here and the map. And this is our map class. And this is the size of the number of elements in the map. And this is a table. And the table is implemented using a list. So this is the constructor here, map. And this is the output. You put the key and value. So this is an entry, a pair of key and value. Remove an entry using the key. So this is the to test if the map contains the key. So this is to test that the map contains the value. So contains an entry that has this value. Items, so we collect all these entries and put it into a list. Get is to return the value using the key. So this is the get all, and you get all the values, and here for this specify the key. So here, and this means what we have here in this case is we allow duplicates. So keys. So the return list all the keys. And this is the return list all the values. Clear is to remove all entries from this map. And this is get size returns the number of elements in the map. That's number of entries in the map. This test if the map is empty. ToString is to return the hash table as a string representation for the map. You can set the load factor threshold and using this method. And this is so here's another ToString, and this is actually so this is the the first one here. This should be deleted. This one is incorrect here. So this is the one here. And now, and this is the get table. It's to return the internal hash table as a string. So let's look at the implementation we have here. So this, if you look at this is the get table, and this is it's ToString. Okay. All right. So first, we're going to define the initial capacity is 4. If you add more elements and that exceed the threshold, and you need to increase the table capacity by doubling it. We're going to set the default max load factor. So that's the threshold, 75%. And the maximum capacity for the table is 2's and power raised to 30. And this is the same as using this bitwise operation. And you have this number binary 1 and shift left 30 times and filling with zeros. So right here, this one is the init method. So you're going to set the capacity and the load factor threshold. And this is the your table, and the initial is empty. And this you're going to get this. You're gonna this every table here, each entry of the table is another list. So the table itself is a list, and each entry in the list is another, is a bucket. Here, this is a bucket, is list. The size is 0 now. So we're gonna have put and key and value, and this is the remove. And so look, when you do a put, you're gonna check the size. If it's greater than or equal to the current size times the load factor threshold, and so that means you need to raise exception because this is the capacity here. So you need to increase the size. Yep. But before you increase size, look at the capacity if it's already reached the maximum capacity, and then we're going to raise exception exceeding maximum capacity. Otherwise, we're going to do rehash. So the rehash is to do this. Rehash is right here, and rehash you're going to increase the table size, doubling it, and then you're going to rehash it. So this is the new table, and we're going to increase. It's increase the capacity here, and then you're going to add the buckets to the table and put the entries back to the table. So here's toString, and this is the okay. Here we have a supplemental hash. So it is this when you do a put. So look, when you do a put right here. So go back to put. So we get a hash. So get a hash is you're getting the hash right here. So here's get a hash. So it returns this supplemental hash, and then this is to get this using this bitwise AND operator, and to compress it to an index in the hash table. All right, so this is all for the implementation of the map class. And so you can look at all the details and how each method is implemented. So those are the time complexity for this operations: clear, contains. So it's order one time. So the get is order one time, and the put is order one time, and remove is order one time. Okay. Now this is a test program and using the map. So you have this map here. You're going to add this. So we have this map, and you're going to put Smith, Anderson, and here Lewis, Cook. So here, and this is the this allows duplicate keys here. All right, so this is the test program and using the map class. That is all for this section on implementing a map using hashing. The next video, we will look at implementing a set using hashing. See you.